Happy Wednesday, everybody. Today we're doing part 2 of the Loksound install on our Kato SD70 Mac. Okay, so now we need to get into a little more of the nitty-gritty in getting some of our function outputs to function properly, and then I had a couple questions on my last video that I wanted to answer. So first and foremost, I bought this model used, and it originally came with an MRC decoder installed. Now, you can tell on the bottom of this that there was once a small speaker on it, but the previous owner put some other sort of speaker, and to my eye, it looks like it is probably a sugar cube speaker, possibly from ESU, but it doesn't really matter as long as you have a speaker that fits your enclosure properly. So it's really more about the resonating chamber, in my opinion, for getting good sound out of your model. But I got rid of that MRC decoder. I ordered this. It said it was sound equipped. I assumed it was a Loksound install, and I was wrong. And the seller basically told me to punch rocks. But anyway, I went ahead and took that decoder out, and I salvaged the speaker that it came with. Now, this goes for any speaker you're installing. You're more than likely going to want a resonating chamber, and because of the size of the MRC decoder that was in this model, there really was no room for a resonating chamber unless you started milling on the frame. So putting an ESU in, you have plenty of room to do that. And I kind of did some looking around on where to buy resonating chambers, and I didn't find a whole lot of information on it. However, I noticed several people online were just 3D printing them. So I have a 3D printer, and I know the basics of my modeling software, so I opened Fusion 360 and put together a relatively simple resonating chamber, and then this is what I came up with. So all I did was take a set of calipers and measured the speaker and verified it was 8 by 15 millimeters. Now, the thickness of your base layer when you're actually creating it in whatever modeling software you're using, I would generally go for whatever thickness or quality thickness, so whatever printing quality you're going with. So in this case, we're using 0.2 millimeter, and that is the thickness of my base layer. From there, I just went a millimeter in all directions for each of my wall thicknesses and extruded this up 1 millimeter. So essentially, it ends up being 5 or 6 layers tall, and I printed this out. It took a couple minutes once the printer was heated up. Just used some regular white PLA, and then with a couple small dots of super glue on the 4 corners, I just glued it to the speaker. Now, there is always a frame that kind of goes around the outside of the speaker, and that is what you're trying to emulate in the wall thickness here. So like I said, I think this might have been an ESU Sugar Cube speaker. I'm not 100% sure. I didn't actually buy it, but the dimensions of this were close enough that they just glued right on and everything worked properly. Then once you have your speaker kind of in there, I generally try to put a little bit of Kapton tape just to kind of isolate the contacts once you have the wires soldered to it and you're ready to rock and roll. Now, I also followed a small tutorial by a guy I found on YouTube where he had mentioned putting in the extra light features on this engine. So I forgot to go over in my last part of this how you actually get those functioning, because you're actually soldering to aux1 and aux2 light outputs. So without changing this on your factory sound profile, they're not actually going to function. So for extra brightness, I went to my F0 in forward, kept my front light on, and added aux1, And in my reverse, I added aux 2. Now, you can't just do this because they're going to act like ditch lights on most sound profiles. So you want to actually go to your function outputs over here. You basically just copy whatever information you already have for your front light. So in my case, I turned on rule 17, so we have automatic dimming when we come to a stop. We want the dimmer enabled, and we're obviously LEDs at this point. So if I go ahead and jump to aux 1, notice I have mirrored all of that information right here. And then same thing goes for your rear light. You just go ahead and mirror all your information over to aux 2. You may or may not want rule 17 in reverse. I choose to have it. Also make sure that you have front light 2 and rear light 2 enabled in here. Basically, you just want to see that it says dimmable headlight. And this is the other thing that I forgot to go over. Because this engine is going to almost never be lead in the consist that I'm running it with, however, it doesn't much matter. It still has headlight functionality. I wanted DPU mode to function. So what I did, because normally function 5 is your DPU mode, and that's now our throttle up feature, I went ahead and went to function 12. Now function 12 doesn't have a whole lot of uses on anything, and it didn't have any sound characteristics set to it. So you need to make some minor adjustments. So you want it only in the forward direction with F12 engaged, and that's just part of your drop-down menu here. You want it in forward, and then you have to come down here and find F12, and I, of course, accidentally hit something there. Once that is there, you want to select your rear light, because this would be at the end of the train. So what this does is if the engine is moving forward at the end of the train, it sets your rear light to be on dim all the time. So it works just like an engine in the prototypical sense. So you want rear light 2. Rear light 2 was the dimmed light. And I'm not really sure if this is necessary, but I always put the dimmer function with this. I'm not sure if that's actually required to make this function. I didn't actually test it, but all of my other models that have DPU enabled have that there as well. The other thing you're going to want to do is scroll down to the bottom of this until you reach the end of your function list. And you're going to want to add the opposite direction of this. So say you are running the engine in reverse, and you activate function 12, you want your front light to act as dim. And then, of course, the dimmer over here. Now, regardless of, because this is not attached to your function 0 forward reverse, this allows some cool functionality. So, for example, if you were running this mid-train and you had all of your light functions turned off, so let's see here. Okay, here's the page. So say you have this in a consist and you don't have your front or rear light enabled. I do all of this inside of my my ESU system that runs my layout, but say you have F0 turned off on this machine running in consist, it doesn't matter, you don't need them on or off to go ahead and get function 12 activated and have those lights be dim. So that's a cool feature. You don't have to actually go back in, open all your settings, and re-enable your lights to make it work. So, alrighty. That is really all of the stuff that you need to change to make this function just like, well, in my case, I'm trying to emulate the Paragon 3 and Paragon 4 function outputs, but it also will work with soundtracks and stuff like that too. The function 5 for throttle up, function 6 for throttle down has been pretty unanimous and, I should say standard amongst most of the decoders for a while now. So this will and does, I have verified, it does run quite well with my Paragon 4s. So I'm going to stop right here. We're going to jump to the layout, and I'm going to talk about some of the issues that I ran into while trying to get this speed matched, because it's a bit of a difficult one. All right, so now we're at the layout, and I wanted to go ahead and film this before I did my my weekly videos. I'm setting up the consist right here to pull a Coltrane for my my shorts this week, and I wanted to use 8987 in consist with my Paragon 4 SD70 Aces. And when I initially set this this Loksound system up, I ran into a lot of issues speed matching, and generally, for the most part, I can just set my CV2, 6, and 5 to their relative values, and for the most part, things usually work out pretty well. However, the throttle curves, for lack of a better word, just were not working out on this Loksound with these Paragon 4s. So I ended up having to use the lock programmer to actually get these to run together. And essentially you do it very similar to how you would normally speed match without a a speed measuring device. So you pick certain values that you want to have the engines work at. So for example, depending on how many speed steps you have set up, I want my engines to all kick on by speed step 2 or what have you, and be running at the same speed at 50% throttle and then at 100% throttle. Because of the difficulty I was having with this Loksound, I determined that I just want to get my below 50% throttle to function perfectly with these guys right here. Now, what I ended up doing was figuring out what my CV2 and my CV6 should be by running them all at the same time and programming that engine on the main. So I set my first speed step, had the engines moving, and I just adjusted the CV value of 2 until they were running perfectly with one another. I'm not terribly worried about the momentum at this point because they're going to be running in consist. This is going to be in the center of these two, so all of the engines should fairly well interact with one another, and you don't have to worry about that as much. But we will touch on how to take some of the momentum out of that. Next, I went ahead and got them running on the outer loop, this one running on the inner loop, and I ran them up to 62, I think, is my medium. Now, I have 126 speed steps. You'd never want to hit 50 because that pushes you into a separate throttle curve, but or 50%, excuse me. So 62 is kind of right there, and that's kind of what I use most of the time on my ESU system for my mid throttle step. Now, if you're using a Digitrax or something of that nature that runs, on 100, always set it at 49. You never want to go into that that second half because you're now into a different speed curve, between CV6 and CV5. So essentially I ran these up and then did the same thing. I sat there and adjusted my CV6 for 8987 until it ran really nicely with them. Now, I thought that would be good enough. I could just set those CVs, but in between those values, I ended up having dramatic issues. So when we get back to the computer here in a moment, I will show you how to use the speed curve and those values that you just got in to get these engines running nicely with one another. You use the CV2 as your low end and your CV6 as the high end, and everything kind of works out from there. So at this point, I have a pretty decent speed match, 89, 87, kind of depending on where we were at in the throttle curve. Can run a little bit faster, a little bit slower, but for the most part, it is good enough to function with these engines. Now, I have some momentum set up on this. For now, I think I will leave it, but in the future, I will probably mess with CV3 and CV4 to actually get some of that out. So now let's go ahead and jump into the computer and start looking at some of the settings that we had to change. Okay, so we're back in software, and I'm not sure I totally understand this, but it does function in this particular case. I'm going to need to do a lot more of these to become more competent in getting the speed curves to function properly and to have a better grasp. But I'm just going to give you the information that I've kind of got figured out so far. I hope to get way more accustomed to this when I start doing those lock pilots in my GP39-2 and GP40, but in this particular instance, these are the numbers that I came up with when I was doing my speed matching. And so my minimum speed, or my minimum start voltage, was 8, and then 65 is what I set as my maximum, or I should say I set as CV6, and it matched my Broadways at my mid speed. Oddly enough, if I put this as my minimum in here and my 65 value as my maximum speed, and then I change my preset to logarithmic, this is the speed curve that I get. Before I did this, if I just set CV2 and CV6 to those respective values, the linearity that the decoder has in it built in, it really doesn't react to the voltages in the way I think it should. It was really slow coming up to speed, and then as I got really close to mid-range, that's when it picked up and started to match my Broadways. And that's kind of one of those weird things you'll get with some decoders. Now, I don't have this problem with my TCS, and honestly, I've never had any of these problems with my scale trains engines running ESUs before. I've always been able to just put the same values in, and I'm good to rock and roll. I think this is because I got an ESU going into a Kato. It's just a different motor profile, and it's not quite the same. So this is what I got to work. I cannot use a linear, throttle curve, for lack of a better word, but if you come in here and you set your minimum speed for your minimum start voltage that you tested, and this is your maximum, and you put a logarithmic curve, at least in the Kato, it has a nice linear speed progression on layout, and it matches what I did with my Broadways. I do have back EMF enabled, and after a bunch of testing, most of my other locomotives generally use a CV3 and CV4 of a value at 20. And this seems to be a good happy medium amongst all of my engines for a good acceleration-deceleration profile, and they all tend to work pretty well together with that value. This engine, however, did not. I ended up changing everything to 10 and rocking and rolling. All of my acceleration-deceleration rates are pretty close amongst it and all my other engines, so I think we're good to go. So now that we've got all of that put in here, we've changed our throttle curve to logarithmic and put up in our mins and maxes, as well as changing all of our function mappings so we have DPU mode re-enabled. This thing works absolutely flawlessly. I'm very excited about the ESU system I put in it. I really like the sound profile that this has, and the way that it throttles up is, in my opinion, far superior to the way, or I should say the sound in which it throttles up is far superior to the Broadways it's running with. Not to mention, it's very, very quiet running in silent mode. This is one of my more silent engines, and that really is something that I find to be important. So it might be the ESU decoder keeping this thing silent. My TCS decoders do a really good job of it too, but once this thing is dialed in, and it did take some time, it certainly is one of my nicest running engines. So anyway, everybody, thanks for stopping by. I appreciate it. I will see you this Friday for our rolling stock review. I got a good one, and I probably won't see you tomorrow, but happy Turkey Day. Alrighty, bye now.